So yeah, we'll be here to talk about the Kernelci.Yml file and standard plans, requirements, and so on. Well, you know me already. You want to introduce yourself?
I'm Kate Stewart. Some of you guys may know me from the SPDX world, the plumbers world, the ELISA world, the Zephyr world. Yeah, I hang around in these sorts of spaces and embedded mostly. Thanks.
Ooh. All right, folks. So we hope this is going to be like more of a discussion. That's like the time that we have for. We have a couple of slides here, but what we want is to drill down a bit more into this idea, which is, I believe, still only an idea of what a standard kernel test plan can be for the community. So, like what we have in Kernel.ci today, this is kind of like a snippet from some things we have and something that I'm inventing in this drawing here for the sake of like showing what we want to do. So you can see, like this is something that I just copied from Kernel.ci. You have like our build configs in there, which branch or the name of the tree. The name of the tree. Our configs, which is something that we don't have the support to do exactly like this in Kernel.ci yet, but the architectures we do, the branch we do, this is another branch in Kernel.ci. And then what we want to do with essentially is to have this file where we can specify a bunch of like the tests that we want to run, and in which scenarios we want to run it, which hardware platforms we want to run it, and so on. So the community starts to have like a standard that's machine readable because it's a YAML file that can be eventually included in the mainline folder. Like we've been hearing from some maintainers that would love to have that file in their subsystem folder. That's also something that you can keep like on your own if you're doing like a series of like scenarios of tests, like for your own like SOC test, for example. You can just like keep it on your own machine, your own folder, etc. What else? Yeah, I think this is also like a step of bringing the possibility of giving more ownership to the maintainers in the kernel community, so they can tell us in more detail what we should be running for their subsystems. One thing that's happening a lot right now, maybe not only in Kernel.ci but other CS systems, is that we are probably in many areas we're not testing enough, but for the things that we are testing right now, we are probably testing too much for certain use cases and demands from some maintainers. Like we were talking to Kevin Hume the other day, for example, and he's like, yeah, but I don't need all those configs you're running. I don't need all those tests. Like I need like this and this and this. Mm-hmm. Unless you go and talk to him, you don't understand that. So we want to really build something that's like a standard across the community. And there's of course something that Kate will talk more. Maybe you want to say a few words already about the safety requirements.
Yeah, so one of the things we're busy looking at is how can we get to a stage of being continuously compliant with the safety use case? Specifically right now, there's a lot of manual effort involved in actually doing the traceability and the analysis associated with proving that something is safe. There's a group of us that believes we should be able to automate a lot of this, and it's hooking on to the requirements. And if a requirement can be tested, then you can pretty much say it is, it closes the loop to some extent. And so if you can say that your set of requirements can be tested after you've made a change and everything is still passing, you have your evidence to prove you've got your safety use case. So in the ELISA project, we're looking at some prototypes in this direction. And one of the reasons we're starting to work with the Kernel.ci community is so that we can see if we can get everything to be unified so that we can actually get to something that's common for both, because there's a lot of commonality that we're going to need. Things like, okay, understanding which configs have you been testing under, which tests are being run, things like that are there at a high level. And we might want to take it down to a slightly finer grain level for some of the cases, but for the most part, the high levels can be fine. It'll be a big improvement over what's there today.
Yeah, sounds good. So in terms of configurations, like here are some examples of things that we are looking at, like coming from the Kernel.ci side here. The branch, the kernel configs, architectures, which test to runs, target platforms. And then there's like more extensions that we can look at, like the expectation files. Like right now we're thinking of a single YAML file, but that can also become the Kernel.ci folder and then a bunch of files inside. That's like how you structure things.
And having those expectation files of saying this is a known set of results that you can test against to say, yes, I have not caused a regression, is really going to be key for the continuous use cases, continuous compliance use cases. And quite frankly, hopefully it'll solve things and make it better for the LTS test infrastructure and make things much more efficient than they are today. That's the other side of it, is trying to get things a little bit more efficient. Mm-hmm. Yeah, please. Okay. Are you good? Okay.
Included in the events, like you send the checkout events or a build events, all this configuration, what you're adding as part of a YAML, let's say I saw your architecture was there, will that be part of the payload of the events which are being sent to the other CI system?
Could be.
Yes, yeah, that's the idea, because if there are CI systems in the ecosystem that's listening to Maestro, and Maestro is able to parse those files, then you are only going to get events from things that were specified in that file, right?
But along with that, you will get other metadata which you have populated.
The mic.
Sorry. Along with that, you will get all the other metadata which you have populated, like architecture, right?
Yeah.
So you're going to have that this is for x86-64, like that, right?
Mm-hmm. Okay. Yeah, correct.
And there are ways of, and there's potential for extension of this type of information into the SPDX format as well, so that we'll be able to have the replay outside of the systems as well. So the conversion into that is one of the things I'm thinking that it should be quite possible. Certainly SPDX in the 2.3 and so forth, we can do YAML files today. Right now for the 3.0 we're doing JSON-LD, but there's no reason we can't do a serialization if there's enough reason to go into YAML. So the format, we're recently format agnostic.
So where are these being stored?
Where will these be stored?
So
In the
there's a few
directory.
options. One that we've been contemplating is that the maintainer would want to store that file in their subsystem folder. We heard that from a few maintainers already. Of course, other maintainers, I think they'll push back on that. But it'll be a maintainer decision of the day to support that file in their subsystem, or Kernel.ci, of course. We already have like some of that information in Kernel.ci. Right now we are reworking the Kernel.ci pipeline to read files like that. So you have to rework the configuration as a whole, like in Kernel.ci. It's not an easy effort right now, but we'll be able to store a lot of the information there as well.
So one thing I'd recommend is that it doesn't look like a file name is standardized, or I would recommend there be a name and a description field inside the file, and that way, if you have a set of directories, you could get a list of the plans that are available.
Self-ID.
So that humans can choose from them or something.
That's a good notion.
Yeah, that's
Self-identification of where you are in that hierarchy effectively in the file, so as it moves, it gets followed. Okay.
I suspect this is mixing two things into one. I think that this would make sense separately, where the part that lives in the kernel describes the kernel code, like what it does, what's like behind it, like does it allocate memory, does it run on a specific device and so on. And then you'll have the other side, like in the tests themselves, like what does this test do, what does it expect to try to like actually achieve. And then you would want to test kind of the intersection between them two, right? Like I don't think it makes sense in one big YAML file inside the kernel.
Yeah. So kind of how we're sort of envisioning this is if we can get to the stage where, and this has come out of the SBOM work, okay, where we start linking all the information together. I'll move her down here, I guess, and talk to it this way. So right now in SPDX today, you can have a relationship called requirements, and you can also talk generation. So you could pretty much do this with what we've got today in SPDX if you wanted to. But the notion is if we have a requirements object, and we say it's requirements for foo, and then we have tests associated with this requirement, when you've generated your image and you put it into your framework and these tests go through your framework, you can get this evidence, and that's evidence for the requirement. So we can put the metadata together to establish this type of traceability. And that's pretty much possible with what we've got today. We just haven't done it in enough of a cases. The thing is, when you have a bug now in a file, you know that, yes, that file really is there, but you can go back to the requirement and say, hey, what tests do I need to rerun to make sure that I've covered my regression cases and I've not introduced anything new? Similarly, I may have had to create a new requirement. I may need to add new tests to make sure that this is coherent. And so if we've got that requirement traceability, we have a framework now to reason about things over time. And realistically, when you've changed a file, you can go to saying, okay, well, there's maybe multiple requirements participating in that file. What do I need to rerun to have confidence that I haven't introduced a regression? So by going from the requirements and all the tests associated with that requirement, you have your framework that you can generate your evidence, and you can say, hey, mission accomplished. I haven't caused a problem, and I've updated things, and I can prove that I'm compliant. And as we get more and more towards being visible about what is in, what the code is doing in the kernel from a requirements perspective, which we've got discussions going on right now, this lets us have a way of also potentially migrating things, quite frankly. So, for instance, if functionality in foo-c and make has moved over to Rust rather than C, if you can rerun the requirement store, you know that you actually have not caused a regression, so you can keep it going. So it gives us ways of looking at things and helping us to keep the functionality, traceable over time. There's certainly a large number of people that are looking at retiring out of the kernel community over time, and there's transitions and so forth. And if we have this stuff surfaced up and we start just applying, these are all software engineering principles from way back. But if we start applying them in a way that we can actually structurally apply them, get to them in a way that works with the kernel's community dynamics, I think will be it'll set the project up for a lot longer lifespan. I've been, like I say, I was very much involved in the real-time, the preempt RT upstreaming and how we got it there bit by bit by bit by bit by putting better things in. And realistically, you've got to make things better. And so this is sort of a proposal for how we can maybe get things going in that direction. Okay? But that's kind of what's in the mind of trying to get the requirements linked to the code and linked to the tests. And so that's what we're trying to see, between the kernel CI and the ELISA community. Can we figure out a way to make this all happen so it's efficient for the kernel and it lets us go for the goals we want? And that sort of brings us to where we are right now. Gustavo, if you want to stand up, I'll go sit. My turn to sit.
Yeah, so we are really like at the beginning of this, and we believe the format and where, like in which ways this should be split, where the information we believe, that's how things that we need feedback on. Like I think we are starting from the kernel side perspective that we want to know like the kernel configs that people want to use. Mm-hmm. We want to know like the hardware platforms they want to test.
Right.
And then depending on the subsystem, they'll have like a specific list of tests. And then from there are requirements and so on.
And realistically, all of those elements are fields I want to make sure we have ways of representing in SPDX so we can convey it in a neutral fashion throughout the ecosystem. So we've got places in the build side for configs, but there may be things for configuring your environment that are beyond just the build for running. So keeping the runtime configs before you run your tests. Mm-hmm. And these sorts of factors are things we have to capture so that we can have the reproducibility. And so understanding what we want to keep as properties and then making sure we have ways of expressing them in a language that's neutral and that we can put into various files and capture the data. That's one thing I've been worrying about. Yeah.
So I think the initial suggestion for adding these test information for subsystems, that's probably realistic, right? You should be able to do that. The only piece I think we have discussed this maybe last year too, I would really want to see the actual command line that we're supposed to run to be able to run this, right? Because it could be subjective for someone to basically look at that string and decide what they're going to do about it. But I think there is a big jump from there to like requirements to source code map to test case. Because right now we're not going to be able to know which source change results in which tests to be executed.
Yep.
But if if we're going to have to come up with all that information, who would be owning that?
So I think we are going to have to cakewalk ourselves there bit by bit, okay? Let's take and do what we can do easily first. There are people who have to take Linux through safety certification who are having to figure this out already. And so give them a way to contribute this information up there and have the maintainers sign off that yes, this is accurate is probably the direction we're going to try to go for at least from the requirements to the code. And I don't see any reason why we can't do it from the requirements to the test, quite frankly.
Yeah.
And so breaking these things apart and considering the requirements to the test as the requirements generating a set of tests that have to run, I think is quite doable. And so we break off that portion right now, focus on that portion here, and let others focusing on the linkage of code to requirements. Like basically Chuck and Gab and myself and the safety architecture working group in ELISA are busy trying to figure out ways that will work for the kernel community to do that. And then Sasha's got some proposals in this direction as well. So I think there'll be another community sort of working around trying to get that level of thing surfaced. But to the extent that we can hook those requirements in a way that we can test them, I think will give us the power we're going to try to need to make some of this continuous compliance actually become a reality.
It just seems that if you don't have the mapping from requirements to the source code, then when the change comes, you have no idea what needs to be tested.
We have ways to do that. Yeah, there was a talk this week here, okay? It was on Monday. And so the video should be up, and you can sort of see what we're looking at there. And it's work in progress, too. This is all work in progress, but if we don't aim for some goal, we never get closer.
Thank you.
Yeah. I think you wanted a question, or no? Okay, you're good. Or comment? Any other thoughts? What about between in the tree? Oops. Okay.
I don't know if this is helpful, but just a stray comment. So the kernel already has a way of mapping source files to maintainers, right? The maintainers file.
Yep.
So.
Oh, yeah.
So, I mean, if you could come up with something even better, that'd be great.
Well, I think leveraging what's there already
Right.
and extending it is the path here.
Yeah, and Nikolai had that suggestion like a year or two ago
Oh.
for adding a field to maintainers indicating the test for a particular subsystem.
That would definitely help too.
Yeah.
Or quite frankly, directly, the question is where are they and how do they find them? Good.
It might be not popular, but I don't think maintainers should control or have an opinion about which tests are running on their subsystem. I think that what we should have is specification of what their code does. And the tests that end up running are just what the tests say they're going to test. So if a maintainer forgets that he needs to test memory allocation in the subsystem, like,
That's true.
right, or which platform it needs to run, or to go run back and update it every time he changes something, I think what the maintainer should have control of is explicitly specifying what the code they wrote is supposed to do, and the tests are just an artifact of what happens there. The documentation is an artifact of what happens there.
Well, the interesting thing is also going to be the side effects of the configurations and how things have been set up and to what level things should be considered to there. Because I think that there's going to be some interesting things to learn there.
I think configurations would need to be specified exactly what they're doing,
Yeah.
not just, yeah.
Yeah, because the configs are going to change things quite dramatically. And Chuck's busy making stand-up noises, or stand-up gestures, I should say.
Yeah, you make a good point. It won't suit us to tie more work into a maintainer. So test, requirements, development, all that. Like the template stuff we're working on for requirements is specifically designed to make maintainers voluntary if they want to do those things. But they can completely ignore it, defer it, whatever. But a lot of that is just like, it has to buy its way on. We always say this, it has to buy its way on. And burdening a maintainer without like instant active profit to make other things easier is like completely not going to happen. So the way to get in, like we're saying, it's a cakewalk and making sure that you're not burdening anybody any further than they already are.
The nice thing too is if we can get this done right, we're going to basically bring a new community into working with the kernel that has not been working with the kernel, which will help the quality, quite frankly. Just in some exercises we've been doing and looking at what the requirements are, we found like 2 bugs by just doing the analysis. And the thing is that there's a whole range of people pointing to that. I'm expecting, quite frankly, as we do the analysis, when we map it into the test, we're going to find there's a lot of gaps in our testing. And this will help us get that visible too. And then quite frankly, hopefully we can even auto-gen some of these tests and get them into the system so we can avoid regressions. I think getting towards the stage where we can auto-gen a lot of the stuff that's missing, I think will help the quality of the kernel, quite frankly.
We have that. It's called syscaller right now. Effectively, it has definition of inputs and expected output, and it will generate tests as long as it can run and find issues, right?
And they find issues, right. So how do we, hooking it all up and making it an efficient way of doing it all is a challenge with some of that. Okay.
Okay. Yeah, I was just thinking on Sasha's point, like that the maintainer might not be the owner of it, right? But we still need to do a total flag testing of it, and right now we don't have anything to understand what are all the test cases that we exercise that part of the kernel.
I don't think we know what our test cases test. I think we have an opinion of what they test. I don't think we know what they test.
That's a good point.
Okay.
Okay.
It's an educated guess. I've been saying that. It's an educated guess right now, unless you have the developer who wrote the code agree that this, well, the requirement is the intermediary. This prose version is exactly what I intended, and then the test meets it. Unless you can show that signed linkage, it's an educated guess. We're smart people. It's probably close, but it's not there.
Does anyone see any problems with us going in this direction?
I wouldn't make it kernel CI specific.
Okay.
Like, I don't think kernel CI is part of this. Kernel CI is something that runs the intersection of requirements and tests, right? I think it would be...
You think we can use it wider? Okay. Right. Okay.
So I guess
Pretty much.
from my perspective, I think that this can be automated long-term automatically by using the makefile and kconfigs that we have in the kernel,
Yeah.
and using just a sat solver. That's, I know,
A what?
a sat solver.
Sorry, new term for me.
Yeah, it's basically going to allow you to do a lot of Boolean logic comparisons and basically try to
Oh,
define-
SAT solver, sorry.
Yes.
Solver. Satisfaction solver, sorry.
Yes.
Sorry, that didn't parse in my head properly. Okay.
So I think that that's the way to grow organically without having to do, even add a file.
How do we hook up to the requirement side of it?
There's limitations to that. It doesn't scale. I mean, we need to do as much of that as possible, but it doesn't scale.
So you don't want to see another file added, is what I just heard.
Not necessarily that.
What I'm trying to figure out is how do we get the traceability and visibility so that we sign off and say, yeah, this is real or not. And committing a file tends to do that.
And having it signed off by.
Pondering, okay.
Everyone's pondering.
Well, no, if you require sign off by the maintainer, you just added a burden to the maintainer.
Yeah, we did. On the other hand, hopefully it'll make the maintainer's life easier when they want to retire.
Well, yeah. Theoretically.
Well, like I said, I'm trying to figure out, improving quality and improving the transition plans, right?
Yeah.
And that's kind of part of, Thomas gets into this too and so forth. So, how do we keep the kernel vibrant for the next 50 years? I think is a good open question. And I think we need to go with something like this where the maintainers have said, yes, this code really does what I've done. I think it does. And here are the tests to prove it. Where, tell me I'm wrong, but I believe there are places in the kernel today where no one wants to touch because the people who understood it are no longer there. And I think getting those pieces under control is a good first area to work on, quite frankly, because it adds value.
The old TTY code and just needs to go away.
Well, that could be too.
Alan Cox back here. It's true that it does add to the burden, but I think there's differences, right? Like if I do a lot of work and create a well-structured set of requirements to an experienced maintainer and just say, did I get it right? Reading and quickly saying, yeah, that's right, or actually I learned from that, right? They can tell pretty quickly that either you get it or you don't get it. And so there's burden and then there's burden. So,
And if you look at this generation of requirements, it's effectively another set of eyes that
Yeah.
haven't looked at the code. So if we're trying to look at more eyes in the code and then getting the tests hooked up to it, I think we get into a more virtuous cycle than we are at right now. But anyhow, if there are people that are interested in participating on this and helping to flesh out what the formats need to look like and how we actually get some of this stuff linked up, I think both Gustavo and myself are very interested in anyone who wants to raise their hands and work with us
Yeah.
as we pull this forward.
And from a Kernel perspective, like there is a minimum here that we still need to do, like for facilitating like the amount of tests that we are doing. Like, of course, I don't think, at least from the discussion, all these we believe like in Kernel CI like standards. But we need to know better like which hardware we need to run like the tests,
Yep.
for example, like and the configurations that maintainers are interested in today, and there's like no other way to do that right now.
Right.
So
I'm recording that.
we need to reduce the noise of the CI system essentially.
It occurs to me that one of the things that would get maintainers really happy is if these ideas would come with hardware to enable testing. So this is an area that we certainly have lacked. I know Kernel CI has its own hardware, but not all kernel maintainers just want to leverage the existing tests in Kernel CI, for instance. So having kernel developers basically giving them the option to run what they want to run for testing, that would probably be a buy-in, I think, from kernel maintainers.
Yeah,
Yeah.
trying to figure out how to get some of the hardware into a pool that we can then they can contribute up the results to, so that others can benefit.
Yeah, the
if they do
hardware one
run.
is a good one, like listing the families of CPUs or hardware vendors, etc. That's one of the
Most vendors, hardware vendors I know, are actually quite happy to donate hardware to kernel maintainers. I really have not had any trouble finding that, and if there's ways that we want to structure a help needed list for hardware, let me know. I can look at that as the other side.
So I guess it's then useful to try to break down these requirements or where this is coming from by different sectors, right? Because it seems like this may be also driven maybe by certain industries. And there are certainly other industries to consider as well. So what I mean by this is that we need to break this down into like maybe embedded and then enterprise type of solutions, right? Because I'm not sure if this is coming from enterprise. It's probably more on the,
My background's coming in from embedded, and so I understand very much you want to have hardware specific to your board configurations, et cetera. And getting that hardware into developers' hands is something that, for instance, on the Zephyr side, which is one of the places I spend a lot of time, we don't generally have a problem finding boards for maintainers that want to work on that, want to do the tests and runs before they finish something off if it touches onto it. However, having a sort of a general system for the kernel and I don't know if there's something that's been set up already. I'm surprised there isn't something set up already for getting boards into maintainers' hands. Tim, was there anything done? No, not that I'm aware of. Okay, interesting. What are we talking about?
From way back.
Yeah.
Mike.
From way back, we tried to set up test labs where we would grant upstream developers access to the labs. And that was always a non-starter because there was a learning curve and no one wants to learn how to use a board in someone else's lab. So you'd think that, and it's the same thing, like even with a bunch of abstraction layers for board management, it's another thing that the maintainer has to learn. So I think the best thing is just to make sure that the results dashboard is suitable. And if the maintainer says, well, I'd like to see what this looks like on such and such a board, then it's kind of incumbent on the lab to make that happen. rather than requiring the maintainer to make it happen.
One of the things that's been interesting from the Zephyr space that maybe we should try and look to see if we can get going here on Linux is Renode has these board simulators that do full emulation of the boards, and basically will basically build Zephyr across all of these targets. So there's 800 boards across 13 apps, and you get the binary, you get the logs, you get all the reference information, and they use that as a way of testing their simulator. Okay?
Right.
So they use the Zephyr infrastructure, and there's no reason that they couldn't be using Linux. They probably have a dashboard for Linux, I just haven't seen it. But there are simulator systems out there that can get you pretty close, and then if you actually need your own physical hardware, there's usually a problem. It's usually a problem with the rev of a silicon, quite frankly. And they've got a lot of stuff with hardware composition. They work with device tree. They work with a lot of the things that the kernel does. So I can certainly take an action to go look and talk to the Microfolk and figure out what they've got available for the kernel community for a variety of different embedded board configurations to help do the testing and emulation across a range of boards, if people are interested in that. But, you know, if a maintainer wants a physical board and is very active with it, if they're not actually part of the company that does that board, usually those companies are willing to give the boards, I've found, in practice. It's just we don't have a sign-up sheet type of thing. I'm a maintainer of this subsystem. I want to test on here. Can you send me a board? Because they don't want to go chase everything, right? Maybe that's something I can talk to the folks at the LF and see if we can find some way of making something happen. I don't know if I can, but I can try.
Yeah. I think a lot, yeah. I mean, wouldn't hurt if such a feature were available or service were available. But like a lot of the upstream developers are not embedded developers. And so there's like, you know, setting up a cross-compile environment and you know.
Yeah, I was gonna say, like, although this focus right now has been mostly on embedded, I see usefulness for this to scale beyond ELISA to also just other enterprise type of hardware, right? And the ideal situation, I think, would be something as easy as we can get access to like a cloud system, right, and an instance, right? So if a solution existed that enabled any kernel developer, whether working on embedded or an enterprise type of server, and they could instantiate instances as easy as we can with like AWS or Azure, for instance, it would be amazing.
Okay, that's a good idea. It's an idea which I think we can, let's keep that one in mind.
Yeah, we can try.
Luckily, this is being recorded, therefore we should be able to review the notes and figure out our action items later, since I'm not taking notes right now.
No, we have the recording of this, so
Yep, that's right.
We should be all fine, yeah.
Okay. Anyone else?
Any more comments, folks? Any other ideas?
Or thoughts on this area? Okay,
Okay, guess that's it then.
very good.
Thank you.
Thank you.